So we're going to look at the Maclaurin series of the trig function sine of x. Um, of course, what we are focusing our attention more in this video is trying to determine, or trying to determine how we come up with these factors that we have down here. Of course, they are part of the coefficients of those terms that we have. Okay, so maybe before we go to that, it's important that we understand what the Maclaurin series is in general. Okay, not in respect to the function that we are dealing with, but just what it is like in general. So one thing that we have to understand is that the Maclaurin series is just a Taylor series that is centered at zero, and we indicate it using the we indicate it like this. We have like the infinite sum, like from n is equals to 0 to positive infinity, and we're going to have um, fn. We have 0 here, then x to the n divide by n factorial. Okay, so looking at what we have right here. Okay, it looking at what we have right here, it basically indicates that when finding the Maclaurin series for this function, we have to differentiate this function up to the seventh power. That is what it indicates. Okay, so of course I'll not really go direct to look at how we come up with this. Of course, that is the main aim for this video, but I would, for the sake of someone who might not really understand how to come up with this, I would like to show um, um, how to show that how that series comes about. It's very, very simple and straightforward. Okay, so the idea is this: you are going to have your function f of x being equals to um, your your sine of x. Then you have to differentiate up to the seventh power as it is indicated there. We just want it to look like what we already have. So it basically means our f prime of x is simply um, cos x. Okay, uh, it's cos x there. Then our f prime prime of what, of x, is what, minus uh, minus sine x. It's very, very important that we pay particular attention to those signs that are alternating. We have a negative, we have a positive, so on and so forth. Then we have f prime prime uh, of x is going to be equals to um, minus cos x. Then the fourth derivative in this case is going to be equals to uh, sine x, simply because the derivative of course is minus sine. That minus multiplied by that other one, you get a positive. Then the fifth derivative, okay, the fifth derivative is going to be cos x. Then the sixth derivative is just going to be equals to minus uh, sine x. Okay, then the seventh derivative is just going to be minus cos what, minus cos x. Okay, so now for us to come up with a series that we are looking for, we should keep in mind to say this here. Okay, that is simply going to give you something like, you're going to have f of, you're going to write it as f of 0 plus your f prime of 0. Okay, then you are going to have your x here plus, you're going to have your f prime prime of 0, then you're going to have x squared divided by 2 factorial plus, you're going to have your f prime 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 there of 0, you're going to have x to the third divide by uh, 3, and like it keeps on going. Okay, so that is how it's going to appear, something close to that. So what it means is that if we are evaluating, or if the center is at 0, it basically means where we have x at these points. Okay, here where we have x, we have to substitute with what, with 0, and see what we are going to get. Okay, now let's see what we are going to get now. If we say f of 0, okay, if we say f of 0, what is it going to be? This is going to be a 0, because sine 0 is a 0. We just substituting with a 0 there, we get a 0. So what about f prime of 0? If we put 0 on cos, you're going to get what? A 1. Okay, so you observe to say the second derivative here, you're going to get what? A 0. Then the third derivative, you're going to get what? um, you're going to get negative 1. We should not ignore the negative. The fourth derivative, you observe to say you're going to get a 0. Then the fifth derivative, okay, the fifth derivative, you observe that you're going to get what? You're going to get a positive 1. Then the sixth derivative, you're going to get what? um, we're going to get a 0 here. Okay, then the seventh derivative, you observe to say we have a negative, but you're going to get a what? We're going to get negative 1, like that. So this is now how it is. You observe to say f of 0, you had a what? You had a 0, you put a 0 like that. Okay, no need to put it. Then f prime of 1 evaluated at 0, it's a 1. So you pick it the way it is here. It's just what? It's just x, and this is the x that we have here. Then looking at the second derivative is 0, so meaning this one goes. The third derivative is negative 1, so this is going to be minus x to the third. Then you have what? You have your 3 factorial there. And you observe to say your fourth derivative will give you a 0, but your fifth is going to give you a plus. So you're going to have like x to the fifth divided by what? Divided by 5 factorial. Then the sixth derivative, you don't have anything, you won't have a 0. Then the seventh gives you a minus 1. That is a coefficient of x, meaning that is your x to the power 7 divided by 7 factorial. And that's how we come up with that one. Okay, so now let's answer the big question. How does the factorial come about? It's pretty easy that it comes from this pattern that we have indicated right here. But someone might really wonder, like, how else, maybe, like, what would what should someone do for it to make more sense that it comes in that way that it does. So now, um, here's something for you. uh, I'm not going to show like all the steps. I'm just going to show maybe for 2 or 3 terms. Then the other terms you can try to come up with them on your own. In fact, I'll try to show for the first one and the second one, which is here we have 1 factorial. If you've observed, here you have 3 factorial, which is a 6. Then for 5 factorial and 7 factorial, try to come up with them and leave your findings in the comment section. Okay, so now the idea is this. We are going to get the function that we have, sine x. Okay, then here on the first one, so what I have here, this series that I have, I'm going to write it as if I don't know the coefficients, where I'm going to have a, let me start from a1x minus a2x to the third plus a3x to the fifth, okay, minus a4x to the what? To the seventh, like that. So here we already know that our a1 is a 1, our a2 is 1 over 3 factorial, our a3 is 1 over 5 factorial, our a4 is 1 over, of course I haven't put the negative in what I'm saying, but we already see the negatives are there. Our a4 is 1 over 7 factorial. Now we want to show that that is true. So what you're going to do is that you have to differentiate this on both sides. So differentiating sine, you get cos. Okay, you get cos x. So differentiating this, what do you get? You get a1 minus 3a2 x to the second plus you get 5a3 x to the fourth minus 7a4 x to the sixth, like that. So now, how you come up with the first coefficient, which is your a1, you have to substitute on every where you have x, you have to indicate with, we have to substitute with what, with a 0. So if you put cos 0 is a 1, is equals to, you're going to have a1 minus, this is going to be 3a2 by 0 squared plus that is 5 a3 0 to the fourth minus 7 a4 0 to the sixth. You observe to say everything here that I've erased gives you what, gives you a 0. So now we have shown that our a1 is a 1, which is true, which is that the coefficient that we have right here. So now what do you do for you to come up with your a2? That is the coefficient for x to the power 3. So what you do is that you have to differentiate this again. You keep on differentiating until you find what you are looking for. So differentiating that, you get minus minus sine what, minus sine x is equals to, you get this is a constant, it goes to 0. So here you're going to have minus 6 a2 x like that plus um, 4 by 5 we get a 20. Okay, so 4 times 5 we get 20, so that would be like 20 a3 x to the third. Okay, minus then we have 7 times 6, that is 42. We have 42 a4 x to the fifth. So you observe to say if you substitute with a 0 here, we're going to get 0 for everything. What do? Differentiate again. Simple. So this is just going to be minus cos x is equals to, so differentiating that, we get minus 6a2 plus that is 20 by 3, we get 60. Okay, we get 60 a3x squared minus, so here differentiating that, we say 42 by 5, we get 210 a4 x to the fourth. So now we can now substitute. So substituting there with a value with x is equals to 0, so we're going to get minus cos 0 is minus 1 is equals to, so putting 0 here and 0 here, you get a 0 because you have an x multiplying by whatever that is, you get a 0. Then here you're going to have minus 6a 6a2. The negative goes, the negative goes. You observe to say your a2 is equals to what? 1 over 6. And you know that your 1 over 6 is simply 1 over 3 factorial, because 3 factorial is a 6. So that is that. And that's how the coefficient comes about. It's very interesting to really find out to say it might not really seem important that why would anyone even be, why would you care that, to find out why it comes out like that. But sometimes it's boring to take things just the way they are. Someone just tells you, okay, this is like this, and you take it the way it is. Like, for me, I find it interesting to really find out where something comes from, such that if I'm writing an assessment and I forget simply because it was just given as a principle or something, if I know how to come up with it, it will be very easy for me to do it on my own. Of course, it will take time, but at the end of the day, it's really the math that really makes sense. Otherwise, that's all in this video. Thank you very much for watching.